Today, we will talk about a very important topic, significant figures. We all know the study of science basically depends on two things. One is observation, another one is measurement. Now for measurement, the measurement should be accurate. Now we all should know that the accuracy of a measurement depends on the number of significant figures. If more number of significant figures are present in a reading, then the reading will be more accurate. If less number of significant figures are present in the reading, then the reading will be less accurate. So now we should know that how to calculate, how to find number of significant figures. So let's start and see what are the rules to find number of significant figures. In decimal system, the numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You have to remember that these digits 1, 2, 3, 4, 5, 6, 7, 8, 9, they are always significant. They are always significant. A is always significant. In any reading, if you see these numbers 1, 2, 3, 4, 5, 6, 7, 8 or 9, then you have to take them as significant numbers. Now for 0, there are three different types of 0. One type of 0 are called trapped 0, another one is called trailing zeros. Trailing 0 are basically ending 0, and the last one is called leading 0. Leading 0. So you have to remember that leading zeros are never significant. Leading zeros are never significant. Trailing zeros are significant if they appear after decimal. If they appear after decimal, then they are significant. Otherwise, not. Otherwise, not. And trapped zeros are always significant. Trapped zeros are always significant. Now we have to know which zeros are known as trapped zeros. Zeros between any two significant figures are called trapped zeros, and trailing zeros are the zeros that appear in the end of any reading. Leading zeros are those zeros that appear in the beginning of any reading. Now, few readings are given here. You have to find the number of significant figures. So, 7, 8, 6. How many significant figures are there? 3 significant figures. This 0 is leading 0. That is why this is never significant. So, how many significant figures are there? 3. And here, how many significant figures? 5 significant figures. Here, this is significant figure. This is significant figure. So, those zeros are basically called trapped zeros. As I told, trapped zeros are basically those zeros that are trapped between two significant numbers, and they are always significant. That is why there are 4 significant figures. How many significant figures are there? These 2 zeros are trapped zeros, so they are significant, as well as this 0 is also significant. So 1, 2, 3, 4, 5, 6. 6 significant figures. How many significant figures are there? 3. No, 5. Why? Because these zeros are trailing 0, but they appear after decimal, because before these zeros, one decimal sign is there. So how many significant figures are there? There are 5 significant figures. In this number, 3 significant figures, because they are trailing zeros, but no decimal is there before these zeros. So that is why they are non-significant. So how many significant figures are there? There are 2 significant figures. Why? Because these zeros are basically leading zeros. Leading zeros. How many significant figures are there? 3. Why? Because this 0 is trailing 0 and it appears after the decimal. That is why it is taken as the significant figures, but these zeros are leading 0. Okay. Now we have to know few more rules to find significant figures. The rules are order of magnitude or power of 10 is never significant. Is never significant. Let's example 6.0 into 10 to the power 3. How many significant figures are there? 2. 2 significant figures. 600 into 10 to the power 4. How many significant figures are there? 1. Because they are trailing zeros, but no decimal is there before those zeros. So 6.00 into 10 to the power minus 4. How many significant figures are there? 1, 2, 3. So 3 significant figures are there. So you have to remember power of 10 or order of magnitude is never significant. Another rule is in a constant number, in any constant, when we are talking about readings, measurements, but in any constant, any pure number, how many significant figures are there? Infinite number of significant figures. Because as I told, that significant number basically defines that the reading is how much accurate. So in any constant, why it is known as constant? Just because its value is fixed. That is why in any constant, how many significant figures are there? There are basically infinite number of significant figures. So basically we calculate number of significant figures in readings, in measurements. Now another rule is, by changing unit, number of significant figures will not change. Remember, by changing unit, the number of significant figures will not change. Just see, 2 kilometer, we can write 2000 meter, it is right. Why? Because one significant figure is there, as well as one significant figure is also there. But this is wrong. Why? Because there are one significant figures, but this is basically a trailing zero which appear after decimal. That is why it is significant. So this is significant, this is significant. These zeros are also trap zeros, so they are also significant. So how many significant figures are there? 1, 2, 3, 4, 5. So it is not possible. By changing unit, number of significant figures will not change. I will give you one more example. 2.0 meter is equal to 200 centimeter. Mathematically this is right, but there are two significant figures, but there are only one significant figures. So it is not possible. As I told, by changing unit, number of significant figures will not change. Now we have to know how will rounding off any value. So now we'll learn rounding off. Now we'll learn rounding off. We have to round off up to two significant figures. We have to round off up to two significant figures. How many significant figures are there? 1, 2, 3. But we have to round off up to two significant figures. So what the value will be? That will be 7.2. But this value will be 7.4. Why, sir? Because here we have to round up to two significant figures. How many digits are there? How many significant figures are there? 1, 2, 3. But we have to round up to 2. So we are looking on this 3. This 3 is basically less than 5. That is why 2 will be as it is, 7.2. But here we are looking on this 6. So this 6 is greater than 5. That is why we have to increase this 3 by 1 unit. So the value will be 7.4, as we know from our junior classes. Here 8 is greater than 5. That is why we have to increase 7 by 1 unit. The result will be 6.8. But what will be the reading if there are 6.752? Then the result will be 6.8. Why? Because this 5 is equal to 5 followed by a non-zero. If this 5 is equal to 5, where is equal to 5, sir? This 1 5 is in our mind, because we know that to round off we have to compare the number with 5. This 3 is less than 5. That is why this is added as it is 2. This 6 is greater than 5. That is why the 3 is increased by 1 unit. It becomes 7.4. This 8 is greater than 5. That is why it is become 7.8. But here this 5 is equal to 5 followed by a non-zero. That is why you have to increase the before digit by 1 unit. The term will be 6.8. Just imagine another reading is 6.759. Then also the result will be 6.8, because 5 equal to 5 followed by a non-zero. That is why you have to increase the before digit by 1 unit. Now what will happen if this thing is there, 6.750. Now 5 equal to 5 followed by a 0. Now we have to see the before term, the before digit of 5. The before digit of 5 is basically an odd number. If this is an odd number, then we have to increase by 1 unit. The result will be 6.8. The result will also be 6.8. Why? Because here 5 equal to 5. Why we are looking for this 5? Because we have to round up to two significant figures. So we have to round up to two significant figures. That is why we are looking on the third number, third digit. That is why we are looking on the third digit. So here third digit is 5 equal to 5, because we know we have to compare all those numbers with 5. So 5 equal to 5 followed by 0. So now we have to apply that before 5 the number is even. So if it is even, it will be as it is. If it is odd, then we have to increase it by 1 unit. If 5 equal to 5 followed by non-zero, then you have to increase it by 1 unit. If the number is greater than 5, that will be increased by 1 unit. If the number is greater than 5, it will be increased by 1 unit. If the number is less than 5, then it will be as it is. This is the rule. For another example, just round off them up to two significant figures. So up to two significant figures, we have to look on this 5. This 5 equal to 5 followed by a non-zero. So the result will be 6.4, because if 5 equal to 5 followed by a non-zero, then we have to increase the before digit by 1 unit. And that one is 5 equal to 5 followed by a 0, and before 5 this digit is odd, so we have to increase by 1 unit. The result will also be 6.4. And here 5 equal to 5 followed by 0, but the before digit is even digit, that is why it will be as it is. It will also be 6.4. Now we will learn in addition, subtraction, multiplication, division, how we have to calculate these significant figures. For addition and subtraction, the rule is the result of addition and subtraction must have the same number of decimal places as present in the value with least decimal places. I know that this definition is very difficult, but you don't need to memorize this definition. Just try to understand the concept. The result of addition and subtraction must have the same number of decimal places as present in the value with least decimal places. That means for addition and subtraction, you have to find the least decimal places. So we are adding these two terms here. In this number, 2 decimal places are there. In this number, only 1 decimal place is there. So in the result, there will be only 1 decimal places. So how we will calculate it? 3.24 plus 0.3. So 4, 5, 3. So in result, how many decimal places will be there? 1 decimal places. So according to the rule, in the result, after decimal, only 1 digit will be there. So now only 1 digit will be there. We have to again round off. We have to apply the round off rule. So this 4, we have to looking on this 4. This 4 is less than 5. So that is why the result will be 3.5 as it is. This is the result. Now for another one, we have to add those numbers. So here 3 decimal places are there. Here 2 decimal places, and here also 2 decimal places. So in the result, how many decimal places will be there? 2 decimal places. So how we will solve it? 0.331 plus 1.12 plus 0.03. So the result will be 1841. So how many decimal places will be there? After decimal, 2 digits will be there. So 2 digits, we have to look in on that one. 1 is less than 5. That is why 8 will be as it is. So the result will be 1.48. This is the result. For multiplication and division, the rule is the result of multiplication and division must have the same number of significant figures as present in the value with least significant figures. So what is the meaning of that rule? For addition and subtraction, the rule was you have to find the least number of decimal places, and here you have to find the number of least significant figures. Here we are multiplying these two terms. Number of significant figures are there 2 significant figures. Here also the number of significant figures are 2. So the result, in the result, how many significant figures will be there? In the result also 2 significant figures will be there. So if you multiply, the value will be 4.41, but in result there will be 2 significant figures. So the result will be 4.4. So what will be the result? The actual result will be 4.4. That will be the result after rounding off. Okay, you have to write this answer in physics. Now, how many significant figures are there? 5 significant figures. Here, how many significant figures? 2 significant figures. So in the result, how many significant figures will be there? In the result, 2 significant figures will be there, because the rule is the result of multiplication and division must have the same number of significant figures as present in the value with least significant figure. So if you multiply, the result will be 32.6738. But that will not be the result, because in result, how many significant figures will be there? 2. So 2 significant figures, but we know we have to round up. So here 6 is greater than 5. That is why the result will be 33. That will be our result. And if you take this division, how many significant figures are there? 2 significant figures. How many significant figures? 2 significant figures. Because this is leading 0, non-significant, this is trailing 0, and decimal is there. So these 2 significant figures are there. And how many significant figures are there? 3. So in result, how many significant figures will be? In result, 2 significant figures there will be. So the result is 0.21126. But in physics, that will not be the reading. You have to write that result is 0.21. That will be the result. Why? Because 2 is the least number of significant figures. So in result, how many significant figures should be there? There will be 2 significant figures. So we have to looking on this one. This one is less than 5. That is why the result will be 0.21. So these are the rules. On the basis of these rules, several numericals already appear in a NEET exam. So in the next video, I'll give few examples of those numericals. Then it will be easier for all of you.